Hello, welcome. In this session, we look at this question which involves a trigonometric equation to solve. And the question says, find in degrees the general solution of sine 7x plus sine x equals cos 4x. So in equations of this form, where there are many trigonometric functions in the same equation, we seek to express any sum or difference of two sines or two cosines into the product of sines and cosines, or product of sines or product of cosines, depending on the situation. And we can do that using any of the factor formula that is suitable for that. In this case, we have sine 7x plus sine x, and actually the factor formula that we can use is sine p plus sine q equals 2 sine p plus q over 2 cos p minus q over 2. So if we apply this to the left hand side of the equation, which is sine 7x plus sine x, we would have that can simplify to 2 sine 7x plus x over 2 cos 7x minus x over 2, which gives 2 sine 4x cos 3x. And so bringing the equation and replacing the left hand side by the simplified form, we have that 2 sine 4x cos 3x equals cos 3x, and then we can send cos 3x to the left hand side, so that we proceed to factorize cos 3x, which is common in the two terms, and dividing every term of the equation on the left hand side by cos 3x, we have 2 sine 4x minus 1 equals 0. And here we have the product of two factors being equal to 0. So whenever that happens, we have to express each of the factors to 0. So because if the product is 0, it is either the first of the factors is 0 or the second of the factors is 0. So we proceed to solve cos 3x equals 0 first, and we have to look for the principal value of the angle there, which is 3x, so that we have the PV, or the principal value of 3x, being the cos inverse of 0, which is 90 degrees. And now we can write the general solution as 3x equals plus or minus 90 degrees plus 360 degrees, n, where n is an integer, which is the general solution when we are solving an equation involving the cosine ratio. And so we can proceed to make x the subject by dividing the equation through by 3, so that we have that one of the solutions is x equals plus or minus 30 degrees plus 120 degrees n, where n is an integer. And clearly you can verify that this actually generates an infinite number of solutions for the equation. If, for instance, n equals 0, we have 120 times 0, which is 0, and we have that x is either 30 degrees or negative 30 degrees. And if you substitute any of those values in the equation, you would see that it satisfies the equation. When n is 1, for instance, you will still have 30 plus 120 degrees, which is 150 degrees, and we also have negative 30 plus 120 degrees, which is 90 degrees. Any of those values, again 90 degrees and 150 degrees, you can verify by substituting them in the equation. You will see that they satisfy the equation. Okay, we take now the other factor, which is 2 sine 4x minus 1, and we equate it to 0, so that we get another solution. Sine 4x, if we make it the subject, we have that sine 4x equals half, and the principal value of the angle there, again, which is 4x, is sine inverse of half, and sine inverse of half is 30 degrees. We can proceed to write that 4x equals the PV into negative 1 to the n plus 180 degrees n, which is the general format for writing the solutions of a trigonometric equation which involves the sine ratio. And from here we can proceed to have the general solution by dividing the equation through by 4, so that we have x equals 7.5 degrees into negative 1 to the n plus 45 degrees n, where n is an integer. Again, if you substitute integral values of n in this equation, we would have an infinite number of solutions to that equation. For instance, when n is 0, I have negative 1 to the 0, which is 1, and 45 times 0 is 0. So we have that 7.5 degrees is one of the solutions to that equation. So if you take, for instance, when n equals 0, you have that negative 1 to the 0 is 1, and 45 times 0 is 0. So 1 times 7.5 degrees will give 7.5 degrees as one of the solutions. And if you verify again in the equation, you will see that it satisfies the equation, and so it is one of the solutions. So we have two general solutions which can be combined to have the general solution as x equals plus or minus 30 degrees plus 120 degrees n, and 7.5 degrees times negative 1 to the n plus 45 degrees n, where n is an integer. So these are all general solutions to that equation. Now, if you are new in this channel, consider subscribing so that you don't miss any of our videos. Thanks very much, and see you in the next video.